if fn and sequence fn and sequence gn converges uniformly on a set A, show that sequence fn plus gn converges uniformly on A. What about sequence fn into gn? Justify your answer. Now solution: let fn converges to f1 uniformly on E, then the given epsilon greater than 0, there exists m0 epsilon belongs to n such that modulus of fnx minus f of x is less than epsilon upon 2 for all values of x belongs to E, and n is greater than equal to m0 epsilon. Again, let gn converges to G uniformly on E, then modulus gnx minus gx is less than epsilon upon 2 for all values of x belongs to E, and n is greater than equal to of m0 epsilon. Therefore, for every x belongs to E, n is greater than equal to of m0 epsilon. So we have, if fn plus gnx minus f plus gx, f plus g into x equals to modulus of fnx plus gnx minus f of x minus g of x equals to modulus of fnx minus f of x plus gnx minus g of x less than modulus of fnx minus f of x plus modulus of gnx minus g of x is less than epsilon upon 2 plus epsilon upon 2 by 1 and 2. Now, which employs fn plus gn into x minus f plus g into x is less than epsilon, which shows that fn plus gn converges uniformly to f plus g on E, but the product of the sequence is not uniformly convergent. Therefore, for example, sequence n plus x plus 1 upon n plus 1 into x and n plus 1 into x square upon 1 plus n square into x square converges uniformly to 1 upon x and 0 respectively on close open interval 0 and 1, but their product of the sequence nx plus x square plus x upon 1 plus n square into x square does not converge uniformly on closed interval 0 to open interval 0 to 1. We have modulus of n plus x plus 1 upon n plus 1 into x minus 1 upon x equals to 1 upon n plus 1 tends to 0, implies that n plus x plus 1 upon n plus 1 into x converges uniformly 1 upon x on open interval 0 to 1, and n plus 1 into x square upon 1 plus n square into x square is less than n plus 1 upon n square tends to 0, implies that n plus 1 into x square upon 1 plus n square into x square converges uniformly to 0 on open interval 0 to 1. Now the product of the sequence nx plus x square plus x upon 1 plus n square plus x square, if at all, the converges uniformly on open interval 0 to 1, then it would converges uniformly to 0 equals to 1 upon x into 0, so that epsilon is 1 upon 4, there exists m belongs to n such that modulus of nx plus x square plus x upon n square into x square is less than 1 upon 4 for all values of n is greater than equal to of m and x belongs to open interval 0 to 1. Therefore n equals to 2m and x equals to 1 upon n belongs to open interval 0 to 1. We have modulus of n into 1 upon n plus 1 upon n square plus 1 upon n upon 1 plus n square into 1 upon n square is greater than 1 upon 2 and less than 1 upon 4. That is 1 upon 2 is less than 1 upon 4, which is not possible. Hence the required product of the sequence does not converges uniformly on open interval 0 to 1. Since the product is of the sequence nx plus x square plus x upon 1 plus n square plus x square tends to 0, therefore the product of the sequence converges pointwise.